The previous few parts, we've talked about writing decorators for functions. And essentially the idea on a decorator is that you take a function and you can put a wrapper layer around it to do interesting things like logging or timing or whatever. The final thing I want to talk about here is how this extends to class definition. To set that up, what I've got is I've got the logging code that we've been applying to functions. And just to refresh your memory on how this actually works, what is happening is I'm importing a decorator function like log, for instance. And then what you do is you define a function. Okay, you have some function being defined like that. And what is actually happening with a decorator is that the function gets replaced by a wrapper. Like you say add is equal to log to add, and logging gets added to it. Turns out that this same idea can be applied to a class definition. For example, if I write a function, I'll write a function decorate, where you give me a class, and I'll put in a print statement here, just sort of saying decorating class, and then return it back. You can do the same thing on a class definition. Like you can say @decorate, and then you can put a class and put, methods on here. Okay, not the most interesting class perhaps, but you can write a class, and what you will see is that decorator function will fire. What it's doing is it's handing you the class definition, and then I'm returning it back. Now, I didn't actually do anything in that example, but this actually opens up kind of another avenue of wrapping code. Here's an example of where I might try to do something like that. Let's say I actually had a class definition. So let's say I had a class in here, like, class spam. And let's say I had a variety of methods. So maybe we have an init method, we'll put an init on it. We'll put a few other methods on the class. Like maybe there's a yow method, grok method, something like that. So we have these different methods on the class. Let's say I wanted to put logging on all of those methods. I wanted to put decorators on those. Like maybe I wanted to say @logged across all of the methods. One of the things that you might logically ask right now is, could there be an easier way to do that? Maybe what I could do is, could I have a decorator that instead of that, you just said log methods, and then I didn't have to apply it to all of the functions there? Could I do something like that? And it turns out that you can do something like that. One of the ways that you could do this is I could write a class decorator. I'm going to make a method. I'll call it log methods. And the idea is you'll give me a class, and what I'm going to do is I'm going to rewrite basically the body of the class. This is going to look a little weird here, but what I'm going to do is I'm going to write a little for loop. So I'm going to say for key value in vars class items. And you're like, okay, what in the world is going on there? I'm going to make a list of the items here. What that first statement is doing is it's actually going to give me a list of everything that's defined in the class. Like if I have a class, if I say vars spam, it actually gives me the class dictionary. It's showing me everything that's in the dictionary. If I say vars spam items, it's giving me key value pairs. And then by converting it into a list, it's giving me basically the contents of the class. So what I'm going to do is I'm going to iterate over the contents of the class here. And I'm going to check to see whether the value is callable. This is essentially asking it, is it a method or not? Is it something that I can call as a function? If it is, maybe I'll turn around and I'll rewrite the class. I'll basically say, okay, well, if it's a method, I'm going to set this to the value with like logged added around it. What I'm doing here, effectively, is some kind of brain surgery on the class. I'm kind of scanning the body of the class, looking for things that are callable, and if I find them, I'm going to put logging on it. Okay, so I'm doing a little bit of brain surgery, and then I'm going to return the class back. You should be really frightened by this, by the way. I mean, the idea of a class coming in and then me doing brain surgery on it and popping it back out. I mean, this is not normally the kind of thing that you would do in a lot of Python code. Let's see if that actually works. So I'm going to come back over to this window here. Let's import that log methods decorator. What I'm going to try to do is see whether that took that class definition and it wrapped all the methods. So if I import sample, okay, it almost worked. I have a little typo in my code here. Not CSL, but CLS. Try that one more time there. Okay, so you see it run, and now all of a sudden you see these messages like, oh yeah, you added logging to init, and to yow, and to grok. Essentially, if you start using that class, you will see the different methods have logging on there. So this is another facet of decorators, essentially, is that you could take like a class definition and then you can start rewriting part of the class definition or filling in details or wrapping things or doing other kinds of things on the class. Turns out that this is a very useful technique for solving a variety of problems involving classes. I thought I would actually look at kind of an example of that that's a little bit more interesting than logging. The example that I thought we would look at is actually this code where we did the type validation. This is from an earlier lesson. We did this example where you could write a class and you could put like type descriptors in here, like name, shares, and price. And then what it was doing was enforcing type checking. Just to refresh your memory on that, the idea is if you worked with this new class holding, okay, so you could make a holding object, it would enforce type correctness because of these like little descriptor objects that I made on there. So if you ever put in a bad value, it would generate a type error. This is some code that we had earlier. Details are not so important, but the underlying mechanism is that we're capturing the dot and wrapping it with kind of a get and a set method like that. Here's one of the annoying things about that code. This actually seems fairly repetitive to me. Like if you look at the code, you'll see things like name equals string name, shares is integer shares, price is equal to float price. Somebody would look at that and say, that's kind of like, why do I have to put the name in there twice? This is the kind of problem that could potentially be solved with a class decorator. Here's how you might solve that. What I'm going to do is I'm going to come up to this like typed class, and I'm going to make the name an optional argument. All of these things need a name, but I'm going to make it optional so that you don't have to provide it. And then what I'm going to do is I'm going to write a little function here. Maybe I'll call this typed, where you give me a class. And my thinking is that I'm going to scan the class. I'm actually going to use exactly the same technique that I had before, where I'm going to scan over the class dictionary, and I'm going to look for the presence of these like typed objects. Like here, you're making typed objects. So what I'm going to do is look for those. I'm going to say, well, if this value here, if that is an instance of one of those typed objects, then what I'm going to do is I'm going to fill in its name. The key is kind of the name that's being used in the class. What's effectively going to happen is the key is that, and I'm copying it over into that typed object. So what I'm going to do is kind of walk through the class, look for those, and then I'll return the class back. By doing that, what I can do is get rid of these extra name arguments. They're going to be filled in automatically as long as I put like a decorator on front of the class. Think of the decorator as kind of assisting with the class definition. It's filling in some missing details for me. So it's like, okay, that's interesting. Actually, let's see if that actually works. Okay, so now we have our holding object. It should work the same as before, and we should see it enforcing some type checking. That's awesome that we can do that. It's like you took that class and you've simplified the definition a little bit, using a class decorator to kind of fill in detail. You could take this in actually a slightly different direction as well. Here's a slightly different decorator that you could provide. I'm going to write a function validate that takes in keyword arguments. And then what I'm going to do is use those keyword arguments to add these typed things to a class. Okay, so we're going to decorate a class. We're going to say for name value and keyword arguments items. Let's go ahead and set an attribute on the class where we fill in the name like this. This will kind of blow your mind in a second here, but what we're doing is providing a decorator with arguments. What I'm going to do with this is I'm going to use it as a way to define the class in a slightly different form. Maybe I'll just do it right here. Instead of typed, I can say @validate, name is equal to string, shares is equal to integer, price is equal to float. What I've done is I've taken these typed things, shoved them up into arguments, and now I don't even have to provide them in the class definition. Essentially what's happening is Python is taking these and then dropping them onto the class, almost as like an optional feature. The val here, by the way, is the thing like integer. I'm giving it the name, which is coming from the keyword there. A lot of interesting things happening there. The insight is that with things like a class decorator, you can write code that does some kind of surgery to the class. You can actually have it fill in details. You can really kind of mold class definitions to do very interesting things and greatly reduce the amount of code that you have to type. So this is, yet another thing you can do with decorators is, apply them to class definitions, do wrapping of methods, you can do surgery on classes. You can really use those to, like clean up the environment in which people are defining objects.